What's up everybody, welcome to MyPixel. As always, it's awesome to have you here. Today we're going to create some enemies and get them moving all over the screen. Because after all, what good are fireballs without something to shoot them at, right? You ready? Okay, let's do it. Okay, so the first thing we're going to do is we're going to create our enemy scene, right? We don't have one yet. So let's just click up here, create a new scene. First thing we're going to do is similar to the player, we're going to put a kinematic body 2D in there. Okay, and we will just name that kinematic body 2D enemy. Okay, the enemy also needs an animated sprite. We also need a collision shape 2D. Okay, to the collision shape 2D, we'll add the collision or the rectangle after we add the animated sprite. So, let's go to the animated sprite. We're gonna add a new sprite frames. Go into those sprite frames. This default animation, we'll just make him walk. Okay. Standard for our project, we're going with a 12 FPS animation, setting a loop to on because we're walking, right? We want that to loop over and over again. Okay, now we need to bring in our sprite frames. Let's go with, I think it's enemy 01. Okay, so we're going walk 0, 1, 2, and 3. Okay, and that's our walk animation. Then we need to set our collision shape. Let's zoom in here. Actually, let's make sure we save our scene here. We're just going to save it as enemy. That's fine. Okay, then we get into our collision shape. We will add a new rectangle shape. And then let's, as best as we can, get it to fit someplace around the elf here that makes sense, right? See how it doesn't line up over here? Typically it's easier to make these things in some multiple of 2 as far as the dimensions, right? Height and width. For these they're not, so I mean it's not a problem. You just can't have collision boxes that fit exactly unless it's a multiple of 2. Okay, so oh shoot, we don't want to do that, right? We don't want to use the outside handles, we only want to use the inside handles. And I accidentally used the outside handles there. So let's not do that. Let's do it the right way. Alright, we'll get there, folks. Alright, let's use a collision box, something like this. Right? This about makes sense. Okay, so that'll be good for his collision box. Okay. Select this so that we don't accidentally pull the collision box off our player anymore. Okay. And then we'll save that. So with that, visually, we have our enemy set up. Now we're going to go ahead and add a script to our enemy. So click on the enemy kinematic body here. We'll just add a script. And you can select all the defaults, that's fine. And let's just get rid of this junk. I don't know if we're going to use the ready function yet, so I'll just leave that in there. Over here, we're going to use the same thing like our player, so we're going to use the physics process to handle our movement and basically almost anything else we do to this elf. Alright, we'll start off, we'll give this elf some constant similar to the player, right? The elf's going to have to obey gravity the same way the player does, so let's give him a constant for gravity. Okay, then we'll give him a constant for his speed. Right, just so that we don't have to modify that speed variable all over the place, right? We don't want to write 30 in 10 different places and write 31 and we have to change them all, so we'll just assign it to the constant speed. Then we're going to have a constant for floor, which if you remember is so that Godot knows which surface to detect as the floor. So vector2 0 comma -1. What else are we gonna do here? Okay, we're gonna create a variable for velocity, and we're just gonna set that equal to an empty vector2, or a vector2 of, if you don't put anything in there, it's effectively 0 0. So it'll just be like that for now. Okay, so then we're going to go into our physics process here. If this is the first video you all are seeing, I know we're going through this a little bit fast, but this is part 8 in the series, so we've already covered a lot of these concepts, so I'm going through it pretty fast. So if you want, you can go and check out an earlier video in the series, and we go at a little bit of slower pace, and you might be able to, or it's a lot easier to pick up what we're doing, right? I go into more detail when we do it, but we're just flying through it now because we've already done this similar type of thing to our player character in the past. Okay, so inside of the physics process, let's set our velocity.x equal to speed. Okay, and from the moment the enemy appears on the screen, we want him to be in his walking animation. So we'll just play the walk animation here. Okay, our velocity.y, right, plus equals gravity. This is so that, right, the whole plus equals, if you don't remember, so that it acts exactly like gravity does. The longer gravity pulls down, the faster you move, so that's why we do a plus equals. Okay, let's see. I like to have these things separated like this. It just helps me to read it. And then we're going to do a velocity equals move and slide. Velocity floor. Okay, and with that we'll save the script and the scene. Now we'll add an instance of the enemy to our stage 1 scene. So let's jump back into our stage 1 scene. Okay, so that we can see. As you can see here, the stage is a little bit bigger than we left it off last time. What I did is I just went ahead and took the liberty of building out the stage bigger so that we'd have more space to put the elves, so that we're not just working on this little bitty portion of the screen. So did that ahead of time. But yeah, that being said, let's go ahead and put our elf in here. So we'll select the stage 1 scene, click this little chain link, select the enemy, and then we'll just drop the enemy in. Well, why don't we drop him just right here? That's fine. He'll do fine right there. Okay, so now he's in here. Let's run the game and see what we have so far. Okay, so there our enemy goes. Okay, he's walked. He's hitting a wall and he's not going anywhere else, right? So our enemy walks until it collides with a wall. Right? That's about right for what we've coded in so far. So now we have to decide, what do we want our enemy to do? How do we want him to move around and react to the different types of environment? Today we'll have our enemy walk in the opposite direction when it hits a wall, and also change direction when it hits the edge or hits the end of a ledge. This is a pretty classic behavior that you'll see in many games like Super Mario Brothers and Mega Man. So let's get in there and code this behavior. First, we're going to have to create a variable to track the enemy's direction. So we'll do that up here. Let's see, we'll just say var direction equals 1. Now in this tutorial series, all sprites and all initial directions that we use are facing to the right. So we always say if the direction equals 1, then that means the direction is to the right. Of course, you can have the number 1 represent the left direction if you want. You just need to make sure to keep things consistent, right? You don't want 1 or the number 1 to represent right sometimes and then have it represent left at other times. Okay, so we'll take this direction and then we're going to have to multiply it into the velocity x calculation. So we're going to go down to our velocity x down here. So instead of velocity x equals speed, we're going to say velocity x equals speed times direction. Okay, so as you can see, right, positive speed would be to the right and negative speed would be to the left, right? So if we have a -1 and we multiply that in there, then we'd get the character moving to the left. So similar to the isOnFloor function that we don't use here, but we use it in the player, there is conveniently a function for isOnWall, which I'm sure you can tell is used to detect when a kinematic body has collided with a wall. So let's go ahead and make use of that. So all the way down here, after we make our character move, we're going to say if isOn, you can see here we have isOn ceiling, wall, floor. This instance we're going to use isOnWall. So if isOnWall, then direction equals direction times -1. So what this says is, as soon as the enemy detects a wall, right, it's going to take -1 and multiply it into its current direction, right, which we already talked about is going to make it go in the opposite direction from whatever it's currently going. So let's run our game and see if that worked. Okay. All right, well, that's the start. Let's see, what do we also have to do? We have to say if isOnWall, then we want him to also flip the sprite, right? So we need to do an animated sprite. Dot, actually, sorry. If isOnWall, I think we should probably do that here. So we'll say if direction. Sorry, let's try this again. Let's do it all the way by where we have the animations. Okay, one more time. Let's see if we get it. If direction is equal to 1, animate sprite, play, walk. No, that's fine. Okay, so if direction is equal to 1, then we're going to say animated sprite dot flip h equals false because he's already facing to the right. Else, basically that's going to be a -1 or anything else, but in this instance we're only going to have -1s. Then animated sprite dot flip h equals to true. Okay, and then I'm always paranoid when I make changes, right, to see if they work. So let's go ahead and do that. Let's see if that worked. Okay, now he's banging into the wall. He changed direction. He's actually colliding with the player also, so then he changed direction. But that's working how we want it to, right? So now what are we going to do? We need to also detect how he's going to find a ledge. Right, so let's go back into our stage 1 scene. Let's grab our player, or not our player, our enemy, and let's stick him up here where there's a ledge, and let's just see what happens. Okay, because we didn't code any behavior for the ledge, right? He only knows how to bang into walls. He doesn't know what happens when he walks off a ledge. He just keeps on walking, gravity takes over, and he falls to the ground. So how are we going to detect that ledge? Now, I'm sure there are many ways you can go about doing this, but today we're going to use a Raycast. If you don't know what a Raycast is, it's basically a line drawn in a given direction, right? You tell it which direction the line should go in. If that line comes into contact with something, then the Raycast will return a bunch of information that we can use to code the rest of our stuff, right? That's the basics of it. So we're going to go ahead and add a raycast to our enemy. So we'll get into our enemy over here. And we're going to add Raycast 2D. Okay. If we'll zoom out over here, you can see this raycast. It's just represented by an arrow. The raycast actually has a 1 or it's a 1 pixel or 0 pixel thickness, but it's just drawn really wide here so that you can see. The only thing that matters is the center of where the raycast is, right? What coordinate it's sitting at. So we're going to take the raycast. Okay, and then let's see where our collision shape is. We're going to want to move the raycast all the way to the front of our collision shape, almost to the front. 1 pixel back. Okay, and then over here where you see this raycast. Actually, before we do that, we need to enable the raycast. If you don't enable the raycast, it does absolutely nothing for you. And for some reason, the default when you add a raycast is off. I'm not sure why it's off, because I would think if you add it, you want to use it and have it enabled. But in any case, make sure you select enable, right? Okay, and then there's this cast to. So instead of 50, we just want to cast it right to where his feet are. Right, so I don't know how many pixels this is. Is it 11 or something like that? 11. It's not the bottom of the arrow where it's going. It's right. If you can see here, right, the 11 that we punched in is right here, right at this the beginning of this arrow, right, where this line meets the triangle. So we're gonna have to use let's use a 12, right, so that it goes right to the feet. That's all we're gonna need to check. In fact, you know what? Just for good measure, let's make that 13. Okay, so we'll go ahead and we will save that. So now our enemy has a raycast added to him. Now with this, our raycast will collide with the ground until the enemy reaches a ledge. When he reaches the ledge, the raycast will no longer be colliding. When the raycast is not colliding, we know that we're beginning to walk off a ledge and that we want to change direction. So let's go ahead and do the code for that. Okay, so we're going to put this after our isOnWall function that we had in here. Let's take out some spaces. So it's going to do its wall check, right? And then change the direction if we hit a wall. And then we also want to check if the raycast is colliding or not, so that we can detect a ledge. So we'll say if raycast 2D dot is colliding equals false, right? So if the raycast is not colliding, then we know we hit a ledge. So at that point, we're just going to do direction equals direction times negative 1. So what we did to direction is the exact same thing that we do to it if it hits a wall. Looks pretty good. Now this is looking good, and you might be tempted to stop here, but we also need to move our raycast. Our raycast starts off by detecting ledges on the right side. If you look at the enemy here, and he's walking this way, he detects a ledge on the right side. Now if he walks to the left, that raycast is still going to be sitting on the right side, and then he won't be able to properly detect the ledge. So what we're going to do is similar to what we did with the position 2D when we were shooting our fireballs. So we're going to add in that code. So under if isOnWall, so if we change the direction, we also need to change the position of our raycast. So we're going to say raycast 2D dot position dot x times where's equals times equals -1. So if the raycast is sitting at, let's just say whatever the coordinates are, a +6, then it's going to go to a -6, which would put it exactly the same distance on the other side of the character, right, when he changes direction. So we need to do that here when he bangs into a wall, and then we'll copy and paste it down here, right? We have to do it here when he walks off a ledge. So in both instances, he'll be able to change direction. Now let's try it out. Now our enemy changes directions after hitting a wall and detecting a ledge, right? Right now he's on the ledge. He's going back and forth. Right, so we know the ledge works. What we can also do is we can put him, let's put him someplace else. So let's put him over here. Okay, so that we know he can detect walls. Right, that's looking pretty good. Alright, we'll even try one more thing. We'll have him detect a ledge or a wall at the same time. So put him right here, right? There's a ledge and a wall over here. And a wall here and a ledge. So we'll have him do that. And he'll just, he goes crazy, right? That looks absolutely ridiculous. But he's doing what we programmed him to do. So that part of it is great, right? Let's just put him back up here for now, right? That's a little bit too spazzy for me. So now our enemy changed direction after hitting a wall, detecting a ledge. Fantastic. Some of you might want the enemy to walk straight off the ledge, right? That sounds great. If that's the case, then you can feel free to just skip the whole part about adding the Raycast to the enemy and all the code that came after that. Then your enemy will be able to ping pong between walls and maybe chase the player down some stairs. Today we created our first enemy and gave it a couple of simple behaviors. Although simple, these behaviors are the bread and butter in a lot of platform games and you should get a lot of usage out of them. Using your creativity, you can take the knowledge you gain about Raycast and then implement additional conditions or behaviors. Maybe you could have the enemy run away when he sees a player, right? You could have the Raycast shoot forward, look for the player. When it hits, he could run away. Or when the enemy sees the player, he could run straight at the player, even faster, and then launch some sort of fancy attack. The possibilities are endless. So that'll do it for today. I'd like to thank you all for watching, and I really hope this helped you out. If you liked today's video, please give it a like and hit that subscribe button if you haven't already. Maybe share this video with a friend, and then we can all make awesome games together. As always, the project folder for today's episode and all other episodes in this series will be available for download on my Patreon page. You simply download the zip file, extract the project folder, and you'll have exactly what I've shown in this video here today. So if you want to check that out and also support the channel, the link will be in the description. And with that, we'll call it a day. So thanks again to everybody for watching, and I'll see you in the next one real soon. Take it easy.